Welcome to All This Math. This is Professor Parker, and today we're going to be multiplying a couple fractions. All right. Now, you might be saying, well, those don't look like no regular fractions. And they might not be regular fractions, but at the end of the day, these are still fractions. This is a fraction, and this is a fraction. Now, when I personally see a problem like this, I get a little excited because this is going to be fun, right? But it's only fun because I know what I'm doing. If you don't know what you're doing, it's not going to be fun. If you don't know what you're doing, it's going to be a nightmare. So what I want to do here is show you how to do this. All right. Now, there are a lot of other skills that you need to already bring to the table in order to simplify a problem like this, or in other words, multiply two fractions like this. Because you can't just, or you don't want to just multiply straight across. What you want to do is, as a first step, take an inventory of what you have in your problem. I got a trinomial, a quadratic trinomial in this numerator. I got a quadratic binomial in this numerator. I got a linear binomial in this numerator. And I got another quadratic trinomial in this numerator. And one of the things I need to be clear about, and I want to point out to you, is that there's a couple things that you might want to do that you can't do in this problem. Like, you might want to do something like cross cancel this y squared with this y squared. But you can't do that because this y squared is part of this trinomial. Like, they roll together, like they're a group. Just like this y squared is part of this trinomial. These three terms, they roll together. They're a group. So you can't just go in here and start canceling stuff out from within the group. But what we can do is factor. We can factor this trinomial, this binomial, and this trinomial. That's the fun part. But it's only fun because I know how to factor. If I ain't know how to factor, then it wouldn't be no fun. So I want you to learn how to factor. All right. Now, there are many different types of ways to factor, and you only know which way to implement if you understand the different methods and know when to use which method. Now, this is a quadratic trinomial, right? Also, the lead coefficient is a 1. So with this one, I'm going to do something that I call reverse FOIL, right? It's basically like doing the FOIL method, but doing it backwards. So I'm going to set it up over here. Now, matter of fact, I'm going to go right here, because that gives me more space. All right, so I'm going to bring this down here, right? So with reverse FOIL, we do two sets of parentheses, right? Now, this first term is y squared. You take the y squared, you break it down into y times y, right? But you put the first y right here and the second y right there. Now, the other two numbers that are going to go here and here, they're like two magic numbers. They're magical because those two numbers multiply to make the last number and at the same time add up to the middle number. Now, this is one method of factoring we can use because we have a quadratic, meaning biggest exponent is a 2, trinomial, 1, 2, 3 terms, and our lead coefficient is an invisible positive 1. All right. So what two numbers multiply to make 9 and also add up to negative 10? It's not 3 and 3, because 3 plus 3 don't add up to negative 10. I could do negatives, though. What about negative 9 times negative 1? That equals 9. And what's negative 9 plus negative 1? Negative 10. So there you go. Those are my two magic numbers. So you put them right there, and that's factored. So this is equal to this. This is broken down into these two binomials. Now, once we break everything down into binomials or whatever individual terms they might be, then we can start canceling things out and simplifying, like the original instructions say. But we got to factor first, though. First, you got to factor. So now I'm going to go down here. I'm going to handle this whole fraction all at once. Now, this is a binomial, right? Now, I always look for a GCF, and I should have said that when I looked at this one, but I just knew that the only GCF was a 1, so that 1 is not going to help us. But you should always look for a GCF, a greatest common factor, in any expression. Now, if I look at this binomial, I'm looking for a greatest common factor. And I know that 2 is a common factor of this term and this term. So watch what I do. I'm going to factor out a 2. Positive 2. Then you put the parentheses. And then you say, okay, well, now the original term divided by the GCF. 2y squared divided by 2 gives me y squared. Negative 2 divided by 2 gives me negative 1. Right? Now, I can factor this binomial again, but I'm going to do that later on. For now, I'm going to leave this here. When you have a binomial that has two terms that are separated by a minus sign, and both terms are perfect squares, that's another type of factoring. And again, it's a lot to remember, but it's not difficult though. It's just a lot. It's not difficult, but it's a lot though. But over time and with a lot of practice, you'll get it. You'll memorize it, right? All right, now on to this fraction. 3y plus 12. Again, check for a GCF. My greatest common factor out of this 3y and this 12 is going to be a 3. So I'm going to factor out a 3, do the parentheses, and now I got to figure out what's going to go inside the parentheses, just like I did right here. I do 3y divided by 3. The 3's cancel out. That gives me a y. Then I do 12 divided by 3, which gives me a 4. So that's positive 4. Boom. Now, this denominator, I got a trinomial. It's a quadratic. Biggest exponent is a 2. Lead coefficient is a 1. Invisible 1 in front of the y squared. It's just like this joint right here. Just like this one, right? So I can factor it the same way, or at least attempt to factor it the same way. Every expression cannot be factored, right? Some are what you call irreducible. That means they are like prime numbers. They can't be factored. So I shouldn't just assume that we're going to be able to factor everything, because that's not real life, right? But let's see if I can factor this one. So first of all, write your two sets of parentheses and take this y squared, break it down. Break the y squared down. It's going to be a y here and a y here, right? Then, again, I need my two magic numbers because I'm doing reverse FOIL. I need my two magic numbers. So I'm looking for factors of negative 36 that add up to negative 5. So think about that for a minute. Factors of negative 36 that are going to add up to negative 5. 12 and 3 ain't going to work. 18 and 2, that ain't going to work. 6 times 6, that ain't going to work. What about 9 and 4? Positive 9, well, no, it can't be positive 9 and positive 4 because that won't multiply to equal negative 36. But I got to make one of the numbers negative. One of my numbers got to be negative. But if I do positive 9 and negative 4, positive 9 times 4 is negative 36. But what's positive 9 plus negative 4? That'll equal negative 5. When that happens, I did that on purpose. When that happens, when you get the right numbers but with the wrong sign, all you got to do is flip the signs. Like I initially said, positive 9 and negative 4, that gave me a 5, but I need a negative 5 though. Make the 9 negative. Just flip the signs, make the 9 negative and make the 4 positive. Whenever that happens, when you got the right number and the wrong sign, write this down in your notebook. When you end up using the reverse FOIL method, right? When you end up with your two magic numbers, when you have the right numbers but the wrong sign, just flip the signs around. So instead of using positive 9 and negative 4, I'm going to use negative 9 and positive 4. So now I got negative 9 and positive 4. All right. Now, I told you I was going to come back to this y squared minus 1, right? Because this y squared minus 1 can be factored out too. So before I move on, I want to factor out the y squared minus 1. So everything else is going to stay the same. Everything else is going to stay the same. And I'm going to factor this y squared minus 1 because that is what we call a difference between perfect squares. A difference between perfect squares. Now, just think about the terminology. The difference, minus sign. Between, the minus sign is in between these two terms. Perfect squares. Y squared is a perfect square because y times y equals y squared. 1 is a perfect square because 1 times 1 equals 1. 1 is a perfect square just like 4 is a perfect square. 9 is a perfect square. 16 is a perfect square because 4 times 4 equals 16. 3 times 3 equals 9. 2 times 2 equals 4. And the list goes on and on. So I'm about to break this down. But I'm going to copy everything over. I'm going to have y minus 9 times y minus 1. Bring the 2 down. I'm going to come back to that. Let me just write these real fast. And I'm just copying everything down. I'm just copying it over because none of this has changed. This is already factored. Now, how do I factor out a difference between perfect squares? In my opinion, it's probably the easiest type of factoring that you'll ever learn, right? all you do is you write 2 sets of parentheses, right? That's your first step. You take the square root of each of the perfect squares. So the square root of y squared is y, right? So you write a y here and a y there. So the square root of the first term will go right here and right here. Then you take the square root of the second term, which is 1. The square root of 1 is 1. So you put a 1 here and a 1 here. Now, you should be wondering, well, how you just going to have y and then a space and a 1? You don't. You're going to put a plus sign in one parentheses and a minus sign in the other one. Just like this. Y plus 1 and y minus 1. Now, does it matter where the plus and minus sign goes? It don't. You could have put the minus sign here and then the plus sign here. It wouldn't make a difference because when you multiply this out, you would still end up with y squared minus 1 as your product because multiplication is commutative. That rule that we learned, that commutative law of multiplication that we learned. And we always think, well, what I need to learn this for? Because it justifies certain things that we can do with our math problems. Now, check it out. Everything is factored. Everything is factored. Now, the fun part is now when you start slashing and canceling things out. So I check for diagonals. I see a y minus 9 right here and a y minus 9 right here. Boom. Cancel them out. And then I got a y plus 4 right here. Now, we can cancel diagonally as well as vertically. We don't cancel horizontally. We don't do that. You don't cancel horizontally. You can cancel diagonally. That's what gave me the right to cancel this y minus 9 with this y minus 9 because they are diagonal from each other. This is in the numerator. This is in the denominator. I can also cancel vertically, straight up and down. So this y plus 4 cancels with that y plus 4. Then over here, y minus 1 cancels with this y minus 1. And they really all turn into ones, right? If you want to be technical, 1, 1, 1, 1, 1, 1. All right. Now, can anything else cancel out? Nah, nothing else can cancel. The 3 and the 2 don't have a common factor besides 1, so we leave them alone. This y plus 1 is just left, right? Now, I'm going to write my answer. Your answer is whatever's left. So in my numerator, I got 1 times 1 times 3 times 1, which is just 3. That's my numerator. Then in my denominator, I got 2 times the quantity y plus 1 times 1 times 1 times 1. So really, I just got 2 times the quantity y plus 1. And that's my final answer. That's it. That's all it is to it. Like I said, like it's fun to me, but it's fun to me because I know how to do it. I know how to factor. So I know I threw like some different methods of factoring at you that you may have never seen before. So what I want you to do is practice. You got to practice factoring quadratic trinomials. You have to practice factoring out the GCF of binomials and practice factoring differences between perfect squares. And there's a couple other different methods of factoring that we use based upon how the expression looks that we didn't get to in this problem, right? But the key to math is just practice. It's all about practice, right? All about practice, repetition, knowing what to do, right? Is one issue, but then also knowing how to do it, right? Knowing what to do and then knowing how to do it. Those are the two key elements just of mathematics in general. All right. So thank you for tuning in. I hope you learned something. Please like the video, subscribe to the page, share the video, tell some other people about it. And always remember, as usual, remember, there's all this math all around you. Peace.